Welcome back to the deep dive. Today we are opening up the hood on something that drives pretty much every major tech conversation we're having right now.
Oh, absolutely. It is everywhere.
Yeah, we are talking about generative AI, but we aren't just talking about the flashy chatbots or the image generators that make funny pictures of cats in spacesuits. We are going way deeper than that today.
We are going to the bedrock. We're talking about the actual science of how these things are built.
Exactly, because here's the situation, and this is really the hook for you listening today. We are living in what people are calling the golden age of large language model.
Right. The LLMs.
You have GPT-4, you have Claude, Gemini. They are just everywhere. They're writing code, they're drafting emails, summarizing your meetings. Commercially, they are incredibly valuable. But there is this massive paradox sitting right in the middle of all this progress.
The black box paradox.
Right. It feels like the better these models get, the less we actually know about them. It's like we went from computer science straight back to alchemy.
That is a perfect analogy. I mean, you have these proprietary models that are gated behind proprietary interfaces and APIs. We see the output, the magic spell, if you will, but the ingredients, the specific architectural choices they made.
The data recipes.
Yes, the data recipes. Those are treated as supreme trade secrets now. And while that might be fantastic for business moats, it is objectively terrible for the science of language models.
Because if you don't know the ingredients, you can't really study the meal. You're just kind of guessing. And that brings us to the star of today's deep dive. We are looking at an extensive release from the Allen Institute for AI, or AI2, along with their partners. They've created something called OLMo.
OLMo. It stands for Open Language Model. And the team at AI2, they aren't just putting out another product to compete with the chatbots. They are on a mission to fundamentally shift the culture of AI research back toward the scientific method.
Now, I got to stop you there for a second. The word open gets thrown around in AI marketing constantly.
Oh, constantly.
I feel like every week a company says they're releasing a truly open model. But reading through the source material for this deep dive, the AI2 team seem to think those other models aren't actually open. So let's unpack this for everyone. What makes OLMo truly open compared to something like, say, Llama from Meta?
It really comes down to the difference between releasing the final product and releasing the entire scientific process. When we look at models like Llama...
Which is widely considered the gold standard for open AI right now, right?
It is, yeah. But Llama essentially provides the training instructions and the model weights. Now, the weights are the final result. That's the trained brain of the neural network. They give you that brain, but they do not release the data set it was trained on.
So sticking with that cooking analogy from earlier, that's like a famous chef giving you a fully baked cake. You can eat it, you can slice it, you can maybe analyze the crumbs under a microscope to guess what's in it, but they absolutely won't give you the recipe, and they won't tell you where they bought the groceries.
Exactly. Or look at MPT. They released a lot of details about their process, but again, not the data set itself. Falcon only partially released their pre-training data.
What about Pythia or Bloom? I know those get brought up a lot in the open source community.
Pythia and Bloom are actually the closest comparisons to what OLMo is doing. They are very transparent. But the difference is that OLMo aims to narrow the performance gap to state-of-the-art capabilities. They want to compete with models like Llama 2 while maintaining that Pythia level of transparency.
Gotcha. So AI2 isn't just releasing the weights, they're releasing what they call the full artifact suite. What exactly is in the suite?
Everything. They released the full model weights at both the 7 billion and 1 billion parameter scales. They released the full training code, the evaluation code. But here is the part that is really a game changer for researchers. They are releasing the training logs and the intermediate checkpoints.
Okay, training logs. I'll be honest, that sounds like the most boring spreadsheet imaginable. Why are researchers excited about logs?
Because it lets them see the metrics during the run. Usually, we only see the valedictorian at graduation. We only see the final result. But OLMo released over 500 intermediate checkpoints.
Wow. 500?
Yeah. These are snapshots of the model's brain at every single stage of its development. You can literally watch it learn. You can see where it struggled, where the loss function spiked, where it finally stabilized.
So instead of just seeing the final test score, you get to see every report card from kindergarten through 12th grade. You can see the exact moment it learned to do math, or when it started understanding syntax.
Precisely. And that allows for actual scientific inquiry into the learning process itself, not just the final capability. If you're trying to figure out why a model hallucinates a fake fact, seeing when that behavior starts during training is invaluable.
And all of this is released under an Apache 2.0 license, right?
Yes, which is a very permissive open source license. You can use it, modify it, study it commercially. It's truly out there.
All right, so that's the open definition. Let's talk about the fuel, the data. Because if you're releasing the data set, you're really bearing your soul as an AI researcher. They gave this data set a specific name.
DOLMa.
DOLMa, like the stuffed grape leaves you get at a Greek restaurant.
Yeah, exactly like that. It actually stands for data to feed OLMo's appetite.
Okay, that is definitely a forced acronym.
A bit of a stretch, yeah.
Yeah.
But the data set itself is incredible. We are talking about 3 trillion tokens.
3 trillion, that's just a massive scale.
Drawn from billions of documents. And because they released the data set, we know exactly what the composition is. A huge portion of it is Common Crawl, which is basically a giant scrape of the open web.
Which is pretty standard for these big models.
It is standard, but they also included code from GitHub, conversations from Reddit, scientific papers from Semantic Scholar, books from Project Gutenberg, and Wikipedia.
Now, when you deal with that much data from the open web and Reddit, you're going to get a lot of noise, a lot of absolute garbage. How did they handle quality control?
They released a companion tool called YMBD.
YMBD?
Yeah, it stands for What's in My Big Data. It's an analysis tool that allows anyone to audit the DOLMa dataset. Instead of AI2 just saying, hey, trust us, we cleaned the data, they are handing the community the microscope to check for themselves.
So if you're listening to this and you want to know if your public blog was used to train OLMo, you could theoretically use YMBD to search for it.
Theoretically, yes. You can check for personally identifiable information or PII. You can check for toxic content. They aren't claiming the data is flawless. Cleaning 3 trillion tokens perfectly is virtually impossible, but they are being completely transparent about what is actually in there.
That transparency is huge.
Yeah.
But there was another specific thing they did with the data called decontamination. And reading the source material, this sounded critical for the integrity of the whole project.
Oh, it's absolutely critical. Imagine you were taking a final exam, but you accidentally memorized the answer key beforehand because the answer key was mixed in with your textbook.
I mean, I would ace that test.
You would get a perfect score. But it wouldn't prove you learned the subject. It just proves you memorized those specific answers. This is a massive problem in AI training. The models are trained on the open internet, and the tests we use to evaluate them are also hosted on the internet.
Oh, so the models just read the test during training. They cheat without knowing it.
Exactly. So the OLMo team explicitly performed decontamination. They systematically removed data related to their benchmarks, specifically the Paloma benchmark from the training set. They made sure that when OLMo takes a test, it is seeing those questions for the very first time.
So the results are honest. It's testing actual reasoning or generalization, not just rote memorization.
Right. It ensures the evaluation metrics are scientifically valid.
Okay, so we have the ingredients, we have the recipe. Let's talk about the oven. The architecture. They built this on the standard transformer architecture, right? The Vaswani one from 2017.
Yes, it's a decoder-only transformer, which is the industry standard for these generative models. But they made some very specific modern tweaks to the design, and this is where we get into the science of stability. Because training these models is incredibly expensive, and they are prone to crashing.
Crashing.
Yeah.
Like getting a blue screen of death on your laptop.
Similar concept, but a multi-million-dollar blue screen of death. When you train a model this big, the mathematical values, the gradients, can suddenly explode or vanish. The training diverges, and you just lose weeks of compute time.
Ouch.
Yeah, so OLMo made choices specifically to prevent that.
Let's unpack some of those nuggets from the design. I saw they mentioned they used no biases.
Right. In the neural network layers, they excluded all bias terms. Now, just to clarify for everyone listening, we aren't talking about social bias or prejudice here. We are talking about a mathematical parameter in the linear layers.
Like the b and the y equals mx plus b equation from algebra.
Exactly that. By removing those bias terms entirely, they found it improved training stability. It simplifies the math during the backward pass, which is when the model learns from its errors. It's a calculated trade-off. You lose a tiny bit of mathematical expressiveness, but you gain a lot of reliability.
They also use something called non-parametric layer norm.
Again, a choice purely for speed and stability. There are different ways to normalize the data as it flows through the network layers. They chose the non-parametric version because it was the safest, fastest option that wouldn't crash the training run.
And what about SWIGLU? That's just a fun word to say. SWIGLU.
It's the activation function. It replaces the older ReLU function. SWIGLU is a trend we've seen in Llama and PaLM. It basically helps the artificial neurons decide what information to pass forward more efficiently. And a really cool detail, they tuned the dimensions to be exact multiples of 128.
Why 128?
Because it makes the math run perfectly smooth on the GPU chips. It maximizes the hardware throughput. Oh, and they also used rotary positional embeddings instead of absolute positional embeddings. It helps the model understand the order of words much better.
And the vocabulary itself?
They base their tokenizer on the GPT Neo X20B vocabulary, but they specially modified it to mask out PII, so it's safer right at the base level.
Now, speaking of the hardware chips,
Yes.
this was actually one of the most fascinating parts of the source material for me, the hardware agnosticism.
This is a massive deal. It honestly might be the most underrated insight from the whole paper.
Because usually whenever we talk about training massive AI models, everyone just assumes you have to use NVIDIA. It's always the H100s or the A100s. NVIDIA has a total monopoly on this space.
Correct. The industry standard software stack, CD, only runs on NVIDIA, but the OLMo team deliberately decided to challenge that bottleneck. They trained this model on two completely different supercomputers with completely different hardware.
So they basically had two different kitchens running the same recipe at the same time.
Exactly. Kitchen 1 was the Mosaic ML platform, which uses NVIDIA A100 GPUs. That's the traditional route. But Kitchen 2 was the LUMI supercomputer.
That's the big one in Europe, right?
Yes, in Finland. And LUMI uses AMD MI250X GPUs.
That's AMD chips, not NVIDIA.
Right. And for a long time, the narrative in the tech world has been that AMD just isn't ready for this level of AI heavy lifting. People thought the software wasn't there, the stability wasn't there, but OLMo proved that wrong.
How did it actually perform on the AMD chips?
They achieved nearly identical performance on both systems. They proved that their open code and this model architecture could run seamlessly across different hardware ecosystems.
That completely breaks the monopoly mindset.
It does. It shows the community that we aren't permanently bottlenecked by one single hardware supplier. If you can train state-of-the-art models on AMD, that opens up so much more compute availability and potentially lowers costs for everyone doing research.
That is just huge for democratizing this tech. All right, so we have the machine, we have the fuel, we know it runs on different engines. But how does it drive? How smart is OLMo, really?
They put it through the ringer with some serious evaluation frameworks. They primarily used Catwalk and Paloma.
Paloma is the benchmark we mentioned earlier, the one they carefully decontaminated the data from.
Yes. Paloma tests perplexity. Now, perplexity is essentially a measure of how surprised the model is by new text. If the model is smart and understands language well, it can predict the next word easily, so it has low perplexity. If it's dumb, it's constantly surprised. And Paloma tests this across 585 different domains.
585 domains. That is thorough.
It covers everything from the New York Times to deep technology papers to the depression subreddit. It is a very diverse linguistic diet.
And how did OLMo stack up against the competition?
It's highly competitive. The OLMo 7B model hangs right in there with Llama 2, MPT-7B, and Falcon 7B.
Is it the best model ever created, though?
No. And honestly, it doesn't try to be. It performs exceptionally well on Common Crawl-heavy evaluations, like the C4 benchmark, because its training diet was nearly 89% Common Crawl. But in some complex reasoning tasks, it might lag slightly behind Llama 2. But you have to remember, the point wasn't to win the leaderboard.
The point was to build a model that is competitive and fully transparent.
Exactly. But they didn't just leave it as a raw base model, they did the adaptation phase too. They fine-tuned it to become a helpful chat assistant.
This is the part where they take the raw, internet-trained brain and actually teach it to be polite and follow instructions.
Right. They used instruction tuning with a dataset mix called 2LU, basically giving it thousands of examples of clear instructions and good responses. And then they follow that up with DPO, which is direct preference optimization, using ultra-feedback data.
Okay, we hear about RLHF a lot, reinforcement learning from human feedback. Is DPO different?
It's a different, much more streamlined path to the same destination. RLHF is very complex. You have to train an entirely separate reward model just to grade the AI's answers. DPO is simpler. You just show the model pairs of answers, like answer A is better than answer B, and you mathematically optimize the model directly to prefer the better format.
And did it work for OLMo?
It worked beautifully. The instruction tuning significantly boosted their MMLU scores, which is a massive multitask test, and it really improved the safety ratings by lowering the toxicity of the output.
Oh, got smarter and cleaner.
In a nutshell, yes.
Now, I want to circle back to something that is almost always ignored in these big AI discussions, and that's the environmental cost. We are burning a staggering amount of electricity to train these things.
Yeah.
Since AI2 is all about full transparency, did they show us the electric bill?
They did, and the comparison between those two supercomputers, the NVIDIA run versus the AMD run, gave us a really eye-opening insight. They estimated the pre-training phase took about 239 megawatt hours of energy.
239 megawatt hours. That is a lot of power.
It is, but the actual carbon footprint depended entirely on where the training happened. The NVIDIA run was hosted in Australia, and the local power grid there has a higher carbon intensity, so that specific training run had a significant carbon footprint.
And the AMD run on the LUMI supercomputer in Finland.
LUMI is powered by 100% renewable hydroelectric power.
So the carbon footprint was zero.
Effectively zero. The carbon intensity was completely negligible.
That is a stark difference. Same model, same training process, totally different impact on the planet.
It really highlights that where you train matters just as much as how you train. If the industry is going to be training thousands of these massive models in the future, moving that compute to renewable heavy grids is going to be essential. And OLMo's transparency finally puts hard numbers on that conversation.
They also were pretty honest about the limitations of the model itself. I mean, usually a press release is all, we solved artificial intelligence. These guys like, well, here is where we fall short.
It's refreshing, isn't it? They openly admit the model is heavily English-focused. So if you want to do high-level translation into other languages, this isn't the right tool yet. They also admit that despite the YMBD tool and the filters, the training data likely still contains some toxic language and PII.
Because perfect removal at 3 trillion tokens is just a pipe dream.
Exactly. And they made a really important point about the benchmarks themselves being noisy.
Which is a very polite scientific way of saying that the tests we use to grade these AIs aren't always great at predicting how useful they will actually be in the real world.
Right. Just because a model scores 2% higher on a rigid multiple-choice test doesn't actually mean it's better at drafting a legal brief or writing code for you.
So bringing this all together, why should you, the listener, care about this? If you aren't an AI researcher, if you're just using these tools to help with your daily work, why does a project like OLMo matter to you?
It matters fundamentally because of trust. As these language models become deeply integrated into our healthcare systems, our legal systems, our education, the old trust us, it works approach from big tech companies just isn't going to cut it anymore.
You can audit a black box.
Exactly. We need to understand why models fail. We need to understand why they hallucinate or show bias in their outputs. OLMo empowers the global community to look under the hood. It shifts the entire conversation from, here is a magic product, to, here is the verifiable proof of how this intelligence was built.
It feels like it democratizes the actual science of it. You don't have to work at a trillion-dollar tech giant to understand the mechanics of AI anymore.
And that is exactly where the next wave of innovation will come from. By giving the recipe in the oven to graduate students, to independent researchers, to startups, we might see massive innovations that the big closed labs completely missed. AI2 is already planning future work with different model sizes, new modalities, and better safety measures.
It really feels like the start of a new chapter, the show your work era of AI.
I certainly hope so. It puts immense pressure on the closed labs to be a little less secretive. Or at the very least, it proves that radical openness is a viable, competitive alternative.
It challenges that whole idea that the best model is just the one with the highest score on a proprietary leaderboard. Maybe the best model is the one that actually teaches us something about intelligence itself.
I couldn't agree more. Scientific knowledge is most valuable when it's shared, not when it's locked in a corporate vault.
Absolutely. And, it leaves you with a pretty provocative thought. If these black box models keep getting integrated into our critical infrastructure, our power grids, our financial markets, at what point does the OLMo level of transparency become more than just a scientific preference?
You mean, when does it become a legal requirement?
Exactly. A mandated glass box. Something to chew on for sure. Well, that is all we have time for today on this deep dive into OLMo. It's a lot to digest. 3 trillion tokens worth of digestion. But hopefully, you have a better sense of what is actually cooking in the open source AI kitchen.
It was a pleasure unpacking it.
We will catch you on the next one. Keep diving deep.